Hi, I am Senorita Dev. I am a PhD scholar in IIT Kharagpur, and I should first tell you that I am recording this meeting. Okay, so with due permission from NPTEL side, I'll upload this video as well, and I will be taking electronic devices, analog circuits, and digital circuits. But first, I want you to tell me how you want to run this session. Today I'll take 1 or 2 questions. I'll try to finish it in 20-25 minutes, and after that actually, or before that, we can actually discuss how the pattern of gate is and how you should prepare. So is this a better idea, or you want me to do only questions? Do you want to discuss how analog questions or EDC questions are? So I'll repeat what I said. I said that do you want me to like discuss the kind of pattern of questions that are there in GATE? Okay, I am getting some yes. Okay. So okay, so I'll start with one. I have to do one GATE 2022 question. I'll do, and one question from GATE 2021. Both are related to MOSFETs. So we'll take that up later. But first, let me discuss the GATE 2022 pattern. Okay, so if you see the GATE paper this year for ECE. Okay, so can you tell me how many of you are from ECE? Is everybody from ECE? Okay, so I think mostly you guys are from ECE. Anyone from electrical or instrumentation? Electrical or instrumentation? Okay, so I think the mostly it is ECE batch. Okay, yeah. So if you see the GATE 2022 pattern of ECE, from semiconductor theory, they had asked 2 1-mark questions. Okay, you might as well write this down if you want. They have asked 2 1-mark questions from semiconductor theory and 2 2-marks question from semiconductor theory. So that is making total 6 marks question from semiconductor theory. Okay. From MOSFETs, there were 2 1-mark question and 4 2 marks question. So 4 into 2 is 8 plus 2, 10 marks question from MOSFETs. And op-amps, they have asked 4 2 marks question. Okay, so I might well share my screen, and I'm stopping my camera so as to save the bandwidth, and it's better, connectivity is better. So I'll just start sharing my screen and write it down so that okay. So my screen is visible, right? Okay, so from semiconductor theory, I'm talking about GATE EC paper 2022. Okay, so from semiconductor theory, one mark question and 2 mark question. So from semiconductor theory, there were 2 questions of 1 mark and 2 questions from 2 mark, and in MOSFETs there were 2 questions from 2 marks, 2 questions from 1 mark, 4 questions from 2 marks, and in op-amps they have asked no question was from 1 mark and 4 questions from 2 marks, and there was one more diode question that was 2 marks as well. Okay, so if you add it up, it makes 2, and here it is 11 questions, right? So total marks is 2 plus 11 into 2, so it's 24 marks, right? Is this fine? 2 questions, 3, 8, 11, 11 to 2, 22. Oh, sorry, this will be 4. So for those who joined late, I am just telling what is the marks distribution in GATE EC 2022 for EDC and analog. So semiconductor theory, they asked 2 questions from 1 mark, MOSFETs 2 questions, and if in 1 mark category, and in 2 marks, semiconductor theory 2 questions, MOSFETs 4 questions, op-amp 4 question, and 1 question from diode. It is making a total of 26 marks, right? Now your technical paper total is 85 marks, right? And if you see the percentage of EDC and analog, it stands to around 30.58%. Okay, so in your entire syllabus, it is not necessary that every year the same distribution will be there for each of the subjects. Okay, the distribution will somewhat change, and EDC analog weightage will never be very less, because it is one of your main subjects. For ECE, it's one of your main subjects, so it won't be very less. Now you see here the marks distribution of MOSFETs. Around 10 marks question is from MOSFETs, which is the highest here, right? Earlier I think it used to be op-amps or something, but not MOSFETs were not that much asked. BJTs were more, op-amps were more, but now the focus is shifting towards MOSFETs, because more and more students are actually focusing towards masters from IC designing, be it in anywhere, in any college, and that's might be the reason why their focus is so much towards MOSFET theory. Okay, so I'll try to take MOSFET theory in a bit detail here in this, because when we start one question, I don't want to just solve that question. I want you to understand the basics of it so that you can solve other questions which are similar, right? That is the goal, that you can solve other questions from MOSFETs theory. If here I am taking 1 or 2 questions, then you can go back and you can revise it, and you can solve other questions as well. Okay, so I'll start with the subject, because most of the students have this question that what textbook to refer to, from where do I practice. These kind of questions are always there. So do you want me to take these general questions now, or do you want me to solve some problem first and then I will take the general question, as you say? So Arnab has replied. Anyone else? So general you want, okay, I think more votes are towards general. Okay, so anyways, problems we will be dealing. Okay, 20 minutes are there for problems. Okay, so one of the questions that you guys have is which books to refer to, right? So see, directly no textbook will be written for GATE. Okay, so no textbook is written for GATE exam, right? So but you want to practice the question. So from where? So there is this SHORM series which is very famous. They have a lot of practice questions. You can practice your questions from there. Okay, practice books. They are available for almost all the GATE syllabus. For ECE especially, they are available for all the GATE syllabus. Okay, SHORM series provides especially useful for signal systems and communication theory. It is especially very useful for this. Signals and communication, very useful. Okay, and you have digital circuits as well, digital circuits, analog circuits, EDC. Networks is also very helpful. Networks is also good. You have EMT. For EMT basic theory it is very good. Okay. Otherwise EMT, the previous year GATE questions are enough for EMT. Okay. EMT basic theory, they are very useful. For mathematics, the GATE questions are enough, because in maths you actually get GATE questions in all the subjects, right? All the subjects are having, computer science is there, electrical, instrumentation. You can pick mathematical maths related questions from any of the disciplines. Okay, so you have a plethora of questions in GATE, a plethora of questions in GATE papers, right? Now in addition to this, from where can you get practice questions? In addition to the SHORM series, from where? So this is a series of books. Okay, these are a series of books. So in addition to this, these PDFs are also, I think, available. You need to search. PDFs are also there. So in addition to this, what you can do is the common subjects with electrical and instrumentation, whatever common subjects you are having, those questions also you can pick up from GATE previous year. Okay, so from GATE previous year, common subjects also you can pick. So I think this will give you a plethora of questions. Now if you want to read the theory, okay, so for reading the theory, there are some standard textbooks are there which you can always find. Analog EDC, normally people refer to Cedra Smith. You can also refer to Streetman Banerjee for EDC. These are very detailed books. You need not read in that much detail for GATE exam, but if you want to go through some basic concepts, this is the main book. Cedra Smith is a very good book. Okay. And for control, normally people use, okay, control systems I did not write here, I think. For control also you have SHORM series is there. Okay, so GATE questions plus SHORM questions, and you have a book of Ogata you have for clearing the doubts. Okay, and for networks, SADIQ is very helpful. You can also practice questions from SADIQ. EMT also, SADIQ's book is there. Okay, this is a different book than network SADIQ. Okay, so this EMT book is a different book, and it has very good transmission lines. Very good questions on transmission lines and EM theory. SADIQ's book, very good question in transmission lines and EM theory. Okay, so signals and communication, mainly you will get it in SHORM series, theory as well as practice question. Digital circuits also, GATE questions are very much helpful. For digital circuits, you actually need to, you can actually practice them yourself, like flip-flops, designing the state machine. You can do it, practices yourself also on the basis of what kind of questions are asked. Okay, you don't always need a textbook for that. You can do it with intuition as well. So these were my list of practice material from where you can get. Okay, so if you have written it down, or maybe taken a screenshot or something, then I will move to the next part. I will talk to the NPTEL coordinator, and if he allows, then I'll put it on YouTube. Okay, but I will definitely encourage you guys to attend these live sessions, because I want to design it in a different way. It won't be only me talking and you listening. So I think it should be beneficial to you. So if you have gone through this, then I will take the next part as to from where to actually read the theory, because only reading books you might not understand each and every concept very well, right? So here you can take the help of NPTEL lectures. Now many students complain about NPTEL lectures that they are very elaborate, they are not completely pointed to GATE. Obviously they are very elaborate because they are for the general mass, right? NPTEL is for the general mass of students. It might not be directly pointed to GATE. But it will cover all the basics needed for your GATE. That is the most important thing. It will cover all the basics of the GATE syllabus. Okay, so I know NPTEL the lectures are very elaborate, so you can choose between the topics. You might skip topics according to your need, that you have to decide. Okay, but I don't think from India any other lecture is better than NPTEL lectures. Okay, so you can take any topic. If you want, I can search some NPTEL. I can search some of the lectures and recommend you that you can take, because one subject has multiple professors taking it. Multiple professors have NPTEL lectures on one particular subject. So if you want, I can choose any one thing, or just to give you a suggestion, I can do that for you. But I think this will be a very good idea to go through NPTEL lectures. Okay. So one mistake that we normally do is we think that okay, in GATE, if there is one question of MOSFET amplifiers, we'll just study some of the basics of the amplifiers and we'll solve it. But you don't know next time what question is going to be set in the paper. For that, you need to have a complete understanding of the basics, and you need to practice well. Okay, so I can suggest you in the next class if you want. Someone has responded to suggest, so I will take this point in that to recommend this. I will check with my fellow mates also what they have gone through, and we can have a recommendation on the basis of this. Now you can think that okay, this eats up a lot of time, so spoon feeding is never a good idea. It will take as much time that what is actually needed for you to understand the theory. Okay, so we have till now gone through first the practice books that you can take to practice questions, and here the first point is, which I should not have missed. GATE previous year is the first point. GATE previous year questions. 15 years, last 15 years you can pick up. Don't go to very old papers like 92, 93, don't go there. Okay, 2022 minus 15, that's it, that is what you need. Okay, so you can start looking to papers after 2007 maybe. Okay, I think 2007 IIT Kanpur had set the paper, so after 2007 you can start looking into it. You can also look into GATE previous year paper with the perspective of which IIT has set. Like suppose you took GATE 2015, say, I think IIT Kanpur had set GATE 2015, and then you can see which all years GATE IIT Kanpur was setting. So let's say IIT Kanpur set in 2007. Before that, let's say it was 2000 or something. I don't remember, okay, I'm just guessing. So now you can actually check the pattern of the questions here. Like which subject was given more importance, what kind of questions were more importance, did they ask more OPAMP in the paper, okay, like those kind of questions you can answer. But remember that don't waste your time in only this thing, only to just to guess, do this guessing work and just to apprehend this thing. Don't waste your time much, okay. So from GATE paper, this analysis that I did, this took me around I think 20 minutes to do this analysis, okay. So 20 minutes to do the EC paper analysis, only one paper. And if you take 10 years paper, so 20 into 10, 200 minutes only for analyzing EDC and analog. Now you have 8 subjects, so 200 minutes into 8, 1600 minutes. So 1600 minutes to analyze which question came from which section. I don't think you should do that, okay. So not this kind of detailed analysis is needed, just a kind of a guess that you just go through the paper, browse through the paper, quickly you look into, okay, this many questions were there, that's it. You need not do this kind of analysis every time with every paper, that will waste your time, okay. So but try to do a quick analysis. Okay, so this is two kind of analysis that I mentioned. Someone is asking, will it be okay? So I'll go through these questions a bit late, okay, like when you should start preparing and all those questions. So when you actually start preparing for GATE exam, you will see that you are unable to answer most of the questions. You are unable to understand what the question is asking. You are unable to solve it, which is obvious. It happens with everybody. So what you should do is, first you should know the theory. So finish the theory first. For example, in analog circuits, you took diode. So diode, you finish the theory first, okay, and then you start with GATE questions previous year, and try to see what all questions you can actually solve. Don't sit with one question the entire day and think that, oh, I am unable to solve and I am good for nothing. That is not good. So you take one question, see if you are able to solve, take the next question from diode itself. From diode theory, try different questions which have been asked in GATE previous years. So first you finish the theory very well, you solve something from the books, and then you go to the set of previous year questions that GATE have given, like GATE previous year questions are there, okay. For every topic you can do that. For every subject this is relevant, okay. Now there is a kind of a sequence also, like how you should start preparing for the subjects. So according to me, like when I had prepared for GATE, I would first do network theory. So network theory will be my first choice, because network theory actually teaches you KCL, KVL, right? All the theorems, Thevenin theorem is there, right? Superposition principle is there. So all these things come in network, and you will see that you have to apply these concepts in analog as well, in control as well, right? So in that case, what will happen is that, one second. Okay, so in that case what will happen is, if you don't have an idea of network theory, if you don't know KVL, KCL, you are unable to do analog also. So first you should start with networks, then parallelly with networks you should start with signals, and I think that is the reason why now they have merged networks and signals in the syllabus, right? So networks, and then you can start with signals. Parallelly you can start with signals, you practice this, then you can start with EDC analog, parallel with digital circuits, okay, and you can take control as well. You can take control fifth, and then you can end it up with EMT mathematics. So this can be your sequence of starting the preparation for GATE. But do networks first, because you need to have a clear understanding of network theory, steady state analysis, because steady state analysis is normally taught in network theory, and it comes in handy in control systems as well, right? It's and very important is transient response. The transient response and steady state analysis is a very important topic, okay? Because what happens in GATE is, if you analyze the question might not be only from network. So what happens is, suppose transient analysis is mentioned in network, you study transient analysis, okay, all the voltage and current across capacitor, that kind of analysis that we do. You have studied transient analysis in network, okay, suppose you have studied it across capacitor, voltages, how to calculate all these things you have studied, right? Now what happened is, in GATE the question will be, there will be an op-amp, there will be resistors, and there will be a capacitor, and there will be some question and they will ask you to find the voltage, some steady state voltage across the capacitor or something like that. So basically what happens in GATE is, they will take questions which will test your network theory as well as your analog concept as well as your control system. So you cannot leave any subject behind. So don't think that, okay, I will not do control system, I will do only network, analog and some other subject and I will go and clear GATE. That is not going to happen, because there might be questions which test all the three subjects. You understand? Is this point clear? So there will be question where there will be a merging of the concepts, okay? So they might give you one PID controller and then start asking you some other question there, okay? So likewise signal systems is also merged with other subjects, okay? So these things can happen. So from GATE previous year question, you will get a clear idea of how questions are framed. So always keep on doing previous year question. There is nothing more important than the GATE previous year question, because they give you a very good idea, okay? So once you have start solving the question, suppose you are very much comfortable in question solving, then you should set timer and solve questions, okay? Set your timer and solve questions, because it might happen that you are able to solve a question but you are taking 20 minutes for it. GATE you don't have that much time, right? So with practice that 20 minutes will reduce down to 2 minutes, 3 minutes, even less than that, okay? You will be able to see a question and answer in seconds also. That comes through practice, okay? So set your timer and check how you are able to do the questions or not, okay? Any more do's and don'ts that I have to check? Okay, so one more point is that when you check the syllabus of GATE, you have to check it thoroughly. That is, suppose in your syllabus it is written diodes, op-amps. Don't think that, okay, diode is there, so application of diode will also be there, right? So don't think that, okay, application of diode is not written, so I will not study rectifier. Application of op-amp is not written, so I will not study any other op-amp, say CCVS circuit or VCVS circuit. I will not study those things. I will not study Schmitt trigger, because it is not written. Don't do that. So if they have written applications of op-amp or op-amp, you should cover all the topics which comes under it. And how will you understand that these are the topics? You have to go to obviously GATE previous year to get an idea. So I think I have told you almost all the topics that I had written down that I should tell you guys. Now I will take your questions one by one. Quickly I will try to go through it, and then we will do 2 questions of MOSFET, okay? So, okay, one student is asking how to revise. Can you suggest an efficient way of revising? Okay, so what you can do is, suppose suppose now you are starting, okay? So you started with 2 subjects per day, network and signal systems. you are listening to some lecture, you are trying to solve, listening to lecture, trying to solve, two subjects per day. Now again, suppose now the network is done, your network theory is done, and now you have to start with control system. So now what you do with control systems, okay, and any other subject in parallel. So I'll just write it down so that you understand more. Suppose I started my theory classes with network and signals. Always try to take one major subject and one minor subject, okay. Suppose I do a 1 hour lecture of network, 1 hour lecture of signal, theory lecture, I am listening to the lecture, and then I spend 1 hour practicing this. Or say 2 hour practicing this, 1 hour it goes nowhere when we start practicing. 2 hour practice and signals, right? We did this. Now next you are, suppose this ends in 1 month, let's say, or 1.5 months. This ends in 1 to 1.5 months, and after that you start control. Now with control what you do, control 1 hour lecture, 2 hour practice, you start revising network here. Do a 1 hour revision of network here, and in parallel you can actually start, if you can, you start with maths. For those who have taken a drop and preparing, for college going students, I think 1 subject per day will be enough. So what my point is, with 1 subject new, one new subject plus 1 old subject revision. That is what I used to do, okay. And prepare short notes, your handwritten notes. Don't buy short notes from anywhere. Prepare your own handwritten notes, keep them with you every time. You guys have phones, iPads now, right? So scan it, keep it in your phone. I will suggest hard copy, because the more you spend, you should spend less time in screen. That is what I believe. So if you can read from hard copy, that is better. So 1 new subject, 1 old subject, 1 new subject, 1 old subject, okay. Now suppose you have already done, you are an experienced person, you have already finished GATE syllabus, everything is done, you are good at practicing also. At that time you can take 2 subjects per day, 3 subjects per day, okay. And don't just mug up, solve it, solve the question. Just take random 5 questions and start solving it. Random 5 questions would do. Even if you have done those 5 questions earlier, don't worry. When you take randomly 5 questions, no, it's pretty new to your brain initially. Unless you have really mugged up that question, it is pretty new to you. So I think revision part is fine. Okay. And okay, one more student has said, I am in first year B Electronics and Communication. Well, some students actually prepare GATE in 3-4 months also. It depends on your kind of preparation, your strategy of preparation. You are in first year, you can well start for GATE. It's a very good time to start. You should start it, take it slowly, go through very good, you have plethora of time, so you can go through NPTEL lectures, you can go through a lot of practice questions available on net, you can go through all the questions that are there in the previous year. Keep on practicing, okay, keep on practicing and revising the theory, otherwise you will forget, okay. Remembering 8 subjects is not easy. The art of remembering 8 subjects is practice and revision. That is how it is done, okay. Can we do book back questions and then get practice questions or GATE practice question? You should always do book back questions first. But remember that there are a lot of questions in back exercises which might not be pertaining exactly to GATE's point of view or the GATE's method. GATE method is nothing but testing you in basics. So for clearing the basics, you should definitely practice the back questions of the book, and then go to the previous year. Don't leave the previous year questions. Very, very important. Okay. Okay, I think there are no more questions. So now, if anybody has any questions, you can directly unmute yourself and also ask. That is also okay for me. You can unmute yourself and ask the question. Okay, so I have seen Utkarsh joining. Utkarsh, are you still there? Utkarsh,
Yes,
hi
yes, ma'am.
Utkarsh. So Utkarsh is actually a master's student. He was a master's student. Sorry, he was a master's student in IIT Kharagpur under VLSI. Utkarsh, if you remember, can you share your GATE rank? What was it?
My rank is AIR 190.
Okay, so he was AIR 190, and can you share where you are working right now with them?
Right now, I am working in Micron as a memory circuit design engineer.
Okay, so
So
Utkarsh,
DRAM,
can you
I will be
quickly give them any experience or any strategy for GATE since you are a good rank holder?
So the key to this success is only the practice. As more as practice, I used to revise the subjects by using questions. Let's say if you've done some subjects, so it's not that you have a grasp, because when I faced a full length subject test, then I feel like I didn't remember anything. So to that, I have overcome a question by to revise certain topic. I used to try to solve those questions on based on those topics. So that's how I able to remember or revise the whole subject in one go.
Okay.
So I will share one link in this chat box.
Okay.
So if they found, they can go through it.
Okay, so I think this is actually entirely for NPTEL. So if you have something from some other kind of, like, it should not be any promotion kind of thing. So
Okay.
otherwise
Yeah.
you can share. Okay, if it's a general website or something, that is fine. Otherwise we should not share, I think.
It's an actually it's an Quora answer written by me itself, so
Oh,
they
okay.
can check me out.
Yeah, then you can share it. If it's an Quora answer. Yeah. Okay.
Okay.
So yeah, so I think Utkarsh cleared it in 2020 GATE.
Yeah.
Yeah, GATE 2020 he cleared. Okay. Yeah, so you are all aware of benefits of GATE that I did not tell you, and I hope you guys understood how he used to do it. And I think any time is fine if you want to start. Okay. Anyone else who is here? I think Sanchari, are you here? Okay, she might not be here. Okay, so I had cleared GATE in 2015 with a good score, and I did my master's from IIT Delhi. So at that time, the way I used to prepare, that is what I shared with you today. So I think I don't have much more time, and I should start with one question. I'm sharing my screen here first so that you guys can have a look into it. So this is the question which was asked in GATE 2022. Should I zoom or is it visible? So I don't want you to see the answers, objectives first. Okay, just want you to see the question. So the ideal long channel N MOSFET and P MOSFET devices shown in the circuits have threshold voltage of 1 volt and minus 1 volt. The MOSFET substrates are connected to their sources. Ignore leakage currents and assume that the capacitors are initially discharged. For the applied voltages as shown, the steady state voltages are. Okay. So, are you writing down the question or? Okay, so you are still able to see that, right? Because I am sharing from another device as well. Are you still able to see the question? Okay, please take a screenshot of it then. Okay, just 1 second. 1 second. Okay, so now I think it is visible. Okay, I've taken the screenshot of the question. So now you guys can also take a screenshot of the question and keep it. So should I start solving the question? Okay, so basically they have given a PMOS and an NMOS, right? And they have given its threshold voltages. So the theory of PMOS and NMOS should be very clear to answer this question. This was a 1 mark question and it is a very good question. Okay, it's a question where mistakes can happen. Okay, 1 mark question. So now what they have given is now can anyone tell me is this a NMOS or a PMOS? Okay, so how did you identify? From its symbol. Okay, yeah, the bubble is not there. So right, right. So now this is the NMOS, this one is the NMOS, this one is the PMOS, right? You understood from the symbol. Now tell me, here they have given that the threshold voltages are 1 volt and minus 1 volt, right? And there is no other information, absolutely no other information given here, right? So how will you identify what is the VGS of the transistor, what is the, so VTH is given, or VTN as is written in some of the books. VTN is 1 volt, mod VTP is 1 volt, right? So can anyone identify which one is the source terminal, which one is the drain terminal? Any one of you? So it is given that the initial voltage of capacitor is discharged, right? So it is 0 volts. So that means here it is 0 volts initially. right? So now can anyone tell me which one is source and gate? We all know this is gate. Which one is source, which one is drain? Anybody? Is the output always taken from drain? So Arnab is saying that output is taken from drain. Plus 5 volt is drain in both the cases. Vidya? You guys can unmute also and tell. I don't have any issue. So plus 5 volt is drain in NMOS case, as I think Vidya is saying. And for PMOS, what will be the drain and what will be the source? Okay. So what happens is, even if you have a symbol like this, even if your symbol is like this as opposed to this, always remember this does not show that this is the source terminal or the drain terminal or whatever. That happens in BJT. BJT is a bipolar device, it's a unipolar device. So what happens here is, in NMOS, the terminal with lower potential will be source. With PMOS, it is just the opposite. Please write this down. Okay. And then with an NMOS, you have VGS, gate to source voltage, VDS, drain to source voltage. This will be positive because source is at lower potential. Okay. With the PMOS, VSG is positive, VSD is positive. Or you can say VGS is negative, VDS is negative. Because here source is at higher potential. Okay. With this concept in mind, let us start the question. Am I going too fast? Okay. So I think it is fine. So this was our problem. We are asked V1 and V2. We are told that capacitor voltages are 0, initial voltages are 0. Then what happens if we make this connection? So now with this concept that we just saw, there is plus 5 volt here, plus 5 volt here. The NMOS actually works as nothing but a kind of a gate here, like it will pass on the signal from this side to this side. It is now stopped here. Okay, this is nothing but like a switch here. Okay, so what happens if you give a plus 5 volt? This is great. This is now source because we saw that source is at lower potential. This one is the drain, right? This is at initially 0 volts. So what is VGS? Turns out to be plus 5. Now this VT N is given as 1 volt, right? That means when VGS is less than 1 volt, this will turn off. The MOSFET will turn off, right? When VGS is less than VTN, MOSFET will turn off. Now what happens? I took the MOSFET, I gave 5 volt in its gate. It had initially 0 volts here. Now when I connect 5 volt here, the capacitor will start charging, right? So the capacitor will start charging, and as soon as it charges to 4 volts, the VGS here, it is still S, right? Because it's still at lower potential. This is drain, it is still drain. because it is as 5 volt. This is still at lower potential. It is charging, it wants to reach to 5 volts. The capacitor voltage wants to reach to 5 volts. It is charging. It reached up to 4. At 4 volts, the VGS becomes 1 volt, and after 4 volts, the VGS starts becoming less than 1 volt. Your MOSFET turns off. Therefore, the voltage V1 is 4 volts. Is this clear? Okay. Now next is your NMOS. Your PMOS. Now here they have given 5, here they have given -5. Okay. Here it is V2. Right. Now here what will happen? Here the V2 can actually charge completely to 5 volts. Can anyone explain why? Because the MOSFET is always on, right? Because it is always on. So NMOS, I have told you how it is happening. I want you to just analyze PMOS quickly and check how it will always be on and always V2 can charge, the capacitor can charge at fully 5 volts. This is what something similar that happens in a CMOS inverter. Okay. So normally CMOS inverter has been asked in question in GATE previous year. So this is what has normally been asked. And if you analyze the working of a CMOS inverter, so your task should be, you analyze CMOS inverter, analyze its characteristics, okay, analyze the voltage characteristics, or I should say input output characteristics, analyze the input output characteristic of CMOS inverter, okay, and we will make some variation in CMOS inverter in next class and see what happens. This is a very important topic, and in future GATE questions might come in from these kind of topics, as I have seen this question came. Okay, this is a similar kind of a problem. So you guys should go through CMOS inverter, and if you want to refer some book, you can refer Veste Harris, PDF is available. Veste Harris or any digital VLSI book can help you. Any digital VLSI book can help you. Please go through the CMOS inverter concept. So this I think is clear. The NMOS, if you want to explain me to explain it some more, I will explain it. And I think if you have understood NMOS, you can do PMOS. It is only you have to find the VGS of mod VGS you find, and you compare with mod VTP as the capacitor charges from 0 to 5 volt. You just make that analysis, and if you make that analysis, you will find that PMOS will always be on. So Soumyadeep has made a statement, so that is true. Okay, so I want all of you to analyze this. So I think I could do only one question. There was one more question, if I can quickly go through it. That was in GATE 2021. So this is more like the DC analysis, right? So the GATE 2021 question is more AC analysis. So if you want, I can go it now. So do you want me to take that question now? Because we are already, it's already I think around 5. Okay. Okay, so let me just take the picture of that first. So you can see the question here. It's visible, I hope. So you can see the question here. It's visible, I hope. So first I will just zoom into this. Okay. So now, if you study from any of your lectures, if you go through any of the theoretical lectures, the book, you will immediately think that okay, I have this circuit, let me draw the small signal model. And the time you think like this in GATE exam, you have messed up. Because small signal model, drawing the model, making the analysis, it might take you say around 5 minutes. There are students, they can solve it in less than 30 seconds. 30 seconds is also too much. Okay. So here where the trick comes in. What is the trick or tip? Right. So I'll tell you that. But first, you should understand that the small signal model is what you should do now. When you are practicing, you should draw the small signal models of the MOSFETs and check. So small signal models are important. And these are important to analyze so that in GATE exam you don't have to sit and analyze. In GATE exam you can just look into the question and mark the answer, because you have only 3 hours in hand, right? And you cannot keep on spending that 3 hours in solving one problem. Okay. So small signal models of the MOSFETs are important to analyze, and solving this you will be actually arriving at the trick of how it is to be done. You yourself have to you yourself will come to analyze it. So if you see, this was a 1 mark question and it is not worth wasting 10 minutes, then why did they give it? So it's pretty easy. You see, this is these two are the MOSFETs. So which kind of MOSFETs are these? NMOS or PMOS? This is a PMOS. So now you see they have mentioned that the transistors M1 and M2 are operating in saturation. They are already in saturation. They have given it. No other information is given except that their transconductances are GM1 and GM2 and their internal resistances are RO1, RO2. Okay, and they have asked you to find what is delta V out by delta V in. So we know that delta V out by delta V in, what it is? It is the total transconductance of the circuit and the total output resistance. Rajneesh is asking what is channel length modulation. So if you want me to go through the topics, I will go in the next class, because right now I'm over time. Okay, they have asked to ignore the body effect, and they have asked the AC small signal. So I will tell you the directly how to see. In the next class I can take this question in detail. So the way you have to solve is, you have to find GM and you have to find R out. GM is the total GM of the circuit. Okay, so now what will happen is, you go through the options. Okay, first is the input transistor is M2. This Vin will be converted to a current GM2 Vin by virtue of this transconductance M2. This current is what is going to be flown through this resistance that is being shown by these MOSFETs. And if you find this voltage, you are done. Right? V out by V in is what you need. So this resistance is nothing but the combined internal resistance of these two MOSFETs. Now what is the resistance? So basically, if you draw the small signal model, you will see that this is called, looking from this node of your output, up is RUP, down is RDN. Okay, R up here is RO1, which is given. R down here is 1 by GM1 in parallel to RO2. This can be approximated as 1 by GM1 as well. Sorry, 1 by GM2. I messed up. 1 by, so for this is the down. So GM1, RO1, and R up is RO2. Right? This is M2, this is M1. So this analysis, if you want, I will do it in the next class. This can be approximated by 1 by GM1. Now in options, 2 of the answers are given, right? But there is no other information as to support these approximations. So that's why your answer is option, this one has to be 1 by GM1, right? So our answer will be option C, because you see B and C are almost similar and they have approximated in option B, right? But they have not given any additional statement in your question to support the approximation. So if option C was not present, our answer would have been option B. But since option C is present, our answer is option C. Okay. So this small signal analysis, I will do it in next class. If you want to have an understanding of these topics, you need to go through the book of Razavi, analog integrated circuits, I think. Yeah. This is in chapter 3.
Ma'am, what book, ma'am?
It's Razavi. I have written it. Razavi, analog integrated circuits, chapter 3. This is an analog IC designing book. Not all questions will be from here in GATE. So you should not go in very much detail. But if you want to have an idea, you can have it from this book. So I think to summarize today's class, I gave you a task of looking into 2 topics. One is the CMOS inverter, and I recommended the book of Weste Harris for this. I gave you a task of looking into small signal analysis of MOSFET, and the help book is Razavi. Okay, so these 2 you can check. One more suggestion, or I want to know from you guys, that if you want this to be a doubt session or not, if you want that I only clear your doubts related to questions, then in that case you need to mail those doubts to me or at least by Wednesday. Okay, you can mail the doubts to me by Wednesday, and I can address those doubts in this Saturday session. That can also be done. So how you want this session to be? You tell me. Like, you want me to take gate questions and solve, or you want me to take particular theory topics and explain it to you, or you want me to just address your doubts, because we have 1 hour session. That's it. So now I want interaction from you.
Topics, ma'am.
I have for analog and EDC, I will take only 1 hour session on Saturdays. There is no other session.
Ma'am, take basic and important topics, ma'am.
Sorry?
First, take important topics, ma'am.
So you want me to take the question and then tell you the topics like I did today, or you want me to take just like the topic and I'll tell you the relevant questions?
First explain the topics and we'll solve the question.
Okay. Okay. So should we start with small signal model next class? Or any other
Yes, ma'am.
topic you guys tell me. So you guys can give some suggestions here for topics. In the chat box you can give me some suggestions. Rajnish is saying CMOS topics. Okay. Small signal of BJT. Okay, Arnab, I have to first check how hot topic a BJT is right now, because from past few years I am seeing that MOSFETs are more being asked. I can take both. So small signal of BJT as well as MOSFET. Okay. Any other topics? Op-amps is clear? MOSCAP, Shekhar, MOSCAP actually, if you see, from MOSCAP they ask very theoretical kind of EDC. It has become a part of EDC, semiconductor theory, right? So if I keep on explaining the entire MOSCAP, no, I think it might be not be a very good use of time. But if you want to study MOSCAP, I can suggest you a good lecture. If you want, you can study MOSFET from NPTEL lectures. It's very good. MOSCAP explanation is too good in. So that's why, like, theoretical topics you guys will get in NPTEL. But like this kind of problem solving you won't get in NPTEL. So we have to balance it. That is what I feel. So next class I will give you a list of NPTEL videos, okay, and definitely Suvarna, NPTEL theory topics will definitely help you in understanding gate topics. Just take the basics, okay, don't go to very high level subjects, take the basics. So I can suggest you guys. So till this 1 week, I can suggest you till this 1 week for EMT, you guys can take Shivgaonkar sir's lecture. Search this, Shivgaonkar sir's lectures from IIT Bombay. I prepared through this. And from control system you can take Ramakrishna Pasamurthy sir's lecture. For CMOS inverters, you can take Janaki Raman sir's, Professor Shivgaonkar sir, Professor Ramakrishna sir, Professor Janaki Raman sir. This is also from IIT Madras, and others I can share you later. As for analog design and analog design, actually Razavi's lectures are there, but they are not pertaining to the BTech level. They start from basic and they go to very high level. So you will have to know that where to stop. Okay, for MOSCAP, you can check Ali Hajmiri's lectures. These are all in YouTube. Okay, analog design, there are more professors, very good lectures from IIT Madras as well, but they are all for analog design. Okay, and this is a very different thing from analog electronics. Analog electronics is right, like you are just starting the basics, and analog design goes to a very high level. Okay, so as for now, you guys can start with this. I will come up with some other lectures as I see. I will just check and I'll let you know. Okay, and I will suggest to go through the topics, because you know I have only 1 hour lecture. In 1 hour I cannot finish small signal of BJT, MOSFET, everything, right? So it's better if I like teach from a gate perspective, like what kind of questions come in gate, those kind of questions I deal, and those kind of topics, like that way if I can explain. Like right now I told you how to you know, look into R up, R down and just get the answer, right? So this is kind of a trick, but if in place of this circuit there is another circuit, you should be able to do that also. So that's why next class I will deal with this. Okay, and I will tell you how to check this. Okay, is that fine, or is it not according to what you were thinking? Any response? Oh, so some of you have given op-amps and frequency response as well. Sorry, I did not see. Of MOSFETs. Yeah, small signal is basically, okay, frequency response of MOSFET. So, anything from your side? I'm thinking I will take those topics which come in gate, mostly asked in gate exam, and I'll take the topic and tell you, okay, these were the questions that were asked. Will that be fine? Okay, all of you are replying with yes. Okay. Okay, so I hope you found this session useful. If any questions are there, I am putting my email ID here. Please mail me your questions. You can mail your questions here. If you have any doubts, please send them by Wednesday every week. By Wednesday, 11:59 PM every week, you can mail the questions, mail your doubts. If you have doubts that you cannot write and mail, then please write down your doubts in your copy, interact your doubts to me in the live session. If I am unable to handle your doubt, I will tell you in the next session, but I will definitely tell you. So let this be a doubt session as well, because I have seen that normally when students prepare for GATE, they get a lot of notes and everything, but there is nobody to solve their doubts, right? So I think it can be a very good doubt session as well. Okay. So is that fine? Can you please respond? Whatever I am thinking.
Okay, ma'am.
Okay. So where are you guys from? Like mostly I think there are many students, around 28 students have joined. So Arnab is from Delhi, Harshal from Ahmedabad, Jyoti from Delhi, Soumyadeep from West Bengal, Gurugram, Coimbatore, Mumbai, Tamil Nadu, West Bengal. Okay, so we have a very beautiful mixture here, right? It's a nice melange. Okay, that's good. So in case you guys want me to change anything or you have any suggestions, you are most welcome to tell me. Okay, please don't be afraid to ask questions. I am also like a student like you. I am a PhD scholar in IIT Kharagpur. Okay, so we all can help each other out. I may not know something you have asked, but I'll definitely find out and tell you. Okay, so I hope this session was interactive, and I'll get to see all you guys next time also, same timing. Okay.